Alright, so let's look at cycloalkane or cycloalkyne group as the substituents. The naming is more or less the same as the class of compound alkane. Okay, so again, all cycloalkane will have the ane suffix as the parent name, and the general formula is CnH2n. So in this table, it shows you the name that for a common cycloalkane. If there is 3 carbon, we call it as cyclopropane. So it is 4 carbon, it is cyclobutane, or ending with ane. And then it's 5 carbon cyclopentane, 6 carbon cyclohexane. If that becomes the substituents, it becomes cyclopropyl ending with YL. Okay, so that means this cyclopropyl attached to the parent chain, cyclobutyl, cyclopentyl, cyclohexyl, and so on. So you just change from the parent name into the substituents YL. So the guideline for cycloalkane naming. So first of all, you need to find the parent. If the number of carbon in a cyclic compound is more than the number of carbon in the substituents, parent will be your cycloalkane. So that means whichever has a higher number of carbon, that will be the parent. But if the main carbon chain contain important functional groups, then the cyclic portion will be considered as your substituent cycloalkyne. So we will look, is there any functional group or the number of carbon in your cyclic compound? So 2 things you need to check. Who will be the parent? Parent will always have the priority. Cyclo, the letter C, will be considered in your alphabetical order. If only one substituent is present, no number is needed. So in the naming, you don't have to put number 1. Number 3, if there are 2 or more identical substituents, find the lowest sets of number. If there are 2 or more different substituents, you need to find the lowest sets of number as well, and you need to number the ring by alphabetical order. This is the case if you got the same number, you get the same lower sets of number, then we will arrange following the alphabetical order. However, we always look at the number first before we arrange the alphabet. Alright, so look at example question 3. Name the following cycloalkane. Alright, so if you look at the substituents, all are alkyl groups, and then the number of carbon is less than the parent. So this cyclic compound will become the parent. Okay, the cyclic compound will become the parent. So the positions, if I put this one as carbon 1, 2, 3, 4, 5, so positions will be at carbon 1 or 3. So similarly, if I turn around another way around, it will also be 1, 2, 3, 1 and 3. Okay, so to see which carbon will be carbon 1 and carbon 3, let's look at the substituents. Okay, the alphabets of our substituents. So for this one, we got 3 carbon as the substituents, which we call it as the propyl. Okay, so using the alphabet P to do our arrangement. And then for this CH3 1 carbon, this is called as methyl group. So we have the alphabets M. So follow alphabets order, M come first before P. Therefore, we need to change the positions. So now carbon 1 will be your methyl group, and then carbon 3 will be the one with your propyl group. Okay, so for this parent, you got 4 carbon. So the parent name will be cyclopentane. Okay, the parent's name will be cyclopentane. And then the positions of your methyl is at 1. So it becomes 1 methyl, and then we have 3 propyl. Remember that there is no spacing in between, so it becomes 1 methyl, 3 propyl cyclopentane. Alright, so for the second structure, so over here you can also see there is a cyclic compound, which is your parent, as the remaining one, we only have 2 carbon, 3 carbon, 4 carbon. So the maximum over here is 5 carbon, which is the parent. Okay, so the name of the parent is the same, cyclopentane. Okay, but now the question is we have 3 substituents. Whether you want to label as 1, 2, 3 or 1, 2, 3, okay, both you have got the lowest set possible, 1, 2, 3, the positions. So now when we want to arrange following the alphabets, okay, so remember, first thing first, find the parent. Second, number. If both of these settle, then we need to look at the alphabet. Okay, so for this substituents, you have to name two carbon, which we call as ethyl with an alphabet E. All right, the second substituent over here is a cyclopropyl. Okay, cyclopropane as the substituents. We take the letter C. Okay, and then this substituent is a sec-butyl. Okay, it attached to the parent with the secondary carbon, and then 4 carbons in this substituents. So the name is called as sec-butyl. So sec-butyl, sec you just ignore, and then we take B as the alphabet to arrange the alphabet. Okay, so we have E, C, and also B. So follow the alphabets. Whichever comes first will be the position. So you choose between 1, 2, 3 with E come first, or 1, 2, 3 with B come first. Okay, so in this case, we are going to choose B start first with this carbon 1, carbon 2, carbon 3. Okay, so the namings of the substituents go this way. 1 sec-butyl, and then followed by 2 cyclopropyl, and then followed by 3 ethyl, and the parent name cyclopentane. You will continue over here 1 sec-butyl, 2 cyclopropyl, 3 ethyl, cyclopentane. Alright, so example questions number 4. Draw the structures of a given compound. So first of all, third butyl 1,1-diethyl cyclopentane. There's no spacing here. So the parent name is cyclopentane. So first of all, we draw the structure of our cyclic compound, cyclopentane 5 carbon. And then we label carbon 1, 2, 3, 4, 5. So at carbon 3, I have a third butyl. So carbon 3, I have a third butyl. Either you draw as the skeletal or condensed structure, both are fine. Okay, for the second substituents over here, both are located at carbon number 1. So 1, 1, 2 positions, that means there's 2 substituents, 2 ethyl group. So at carbon number 1 here, I have 1 ethyl group, 2 carbons, so 1, 2, and then another substituents 1, 2. So if you want to look at this condensed structure, alright, so it will look something like this. CH2, CH3 with the substituents at carbon number 1, CH2, CH3. And then substituents number 3 here, third butyl, it looks something like this. CH3, CH3, CH3. Or you can also condense them all together, C and then CH3 inside the bracket. Okay, something like that. Alright, for questions B, 2-cyclobutyl-hexane. So now the parent is hexane. Please pay attention to the word cyclo. If cyclopentane, that is a cyclic structure like this. If it's just hexane, okay, without the word cyclo, that means it's a straight chain carbon chain. So hexane with 6 carbons. So in this case, you need to draw 6 carbon in your main chain. So I label as carbon 1, 2, 3, 4, 5, 6. Okay, and then carbon number 2, I have a cyclobutyl. Butyl, it means 4 carbon in a cyclic structure. Carbon number 2 with 4 carbon inside a cyclic structure. Okay, let's check again. This is extra questions for you. Draw the structures or name the following compound. So if you are given the name, okay, first of all, check your parent. This is a cyclic structure, cyclohexane. So that means you will have a cyclic structure with 6 carbon inside it. And label carbon 1, 2, 3, 4, 5, 6. Doesn't matter where you want to start as carbon 1. Okay, so carbon 1 isopropyl. So the structures look something like this. And then at carbon number 2, we'll have a methyl group. Okay, so this is structure 1 isopropyl, 2 methyl cyclohexane. The second structures give you over here. So let's check which one is your parent. So looking at this cyclic compound, you only got 4 carbon. And then this straight chain, you have 5 carbon. So the straight chain, because of the greater number, it becomes the parent. Okay, so the parent having 5 carbon, it called a pentane. So at positions number 3, there is a cyclic structure as the substituent. So we name it as cyclobutyl. Okay, 4 carbon butyl. So 3 cyclobutyl pentane. And the next structures over here, if you compare, there is 4 carbon in the cyclic, 4 carbon in the main chain. In the main chain over here. So the cyclic compound will becomes the parent. Okay, the cyclic compound will become the parent. So this is positions number 1. Only one substituents, you don't have to put number. So this is a secondary carbon, and you have 4 carbon in this substituent. So this is actually our sec-butyl cyclobutane. Or if you want to name according to IUPAC naming, can as well. You can name this carbon which direct attached to the parent as carbon 1, 2, 3. This is a substituent inside the substituents. So we can write as we can write 1 methyl propyl, which is the substituents, and then the parent, which is your cyclobutane. So the sec-butyl will be slightly easier, but you have to memorize the structure.